everybody, I wanted to do a little video for the Module 3 notes. You will notice that there is a copy of the completed notes up in Lumen, so I won't go through every word of this, especially the things that you need to copy down, because you can copy it from there, or you can just pause this video if you would like. So at the beginning here we have some of the vocabulary words. This whole module is about probability, which is the likelihood of a specific outcome happening. An experiment is a planned operation that is carried out under controlled conditions. So in an experiment, we're purposely doing something. We're not just observing, but we're purposely rolling a die or looking at whatever information it is. And then that experiment will have an outcome or a result of that experiment. The sample space is the set of all possible outcomes. And an event is a specific set of outcomes of an experiment, or it's a subset or part of the sample space. So let's pretend that we were going to reach into a jar and pull out one of these little blocks here, okay? So my sample space would be the set of all possible outcomes. And if all my purples, let's say, are the same, so it doesn't matter which purple I choose, then my sample space would be that I would pick out a blue, purple, or a green, right? Sometimes we may want to write out there's a blue, 3 purples, and 2 greens. So then the event, maybe the event is that I pick out a purple or a blue, right? That's a subset of my sample space. So what I'm looking at is what's the probability of this specific event or outcome happening. Maybe that event is that I pick out one of these. The probability of that happening, we know often, you probably remember from other classes, we do a fraction with the number of possible outcomes that we're looking for over the total number of possible outcomes. So if these are my 6 little blocks in my bag and I'm going to reach in and pick one out and I want to know the probability of picking out a green, for example, it would be 2 out of 6, 2 over 6, because there are 2 greens out of 6 total options. So again, if you need to copy those over, you can either get them off the completed notes or you can just pause the video for a minute. We talked a little bit before about this law of large numbers with sampling, that the more samples we take from a population, the more the population or the sample values get closer and closer to the population values. And the same idea happens here. As the number of repetitions of an experiment is increased, the average of the results should be close to the expected or theoretical probability. Best way to think about this is when thinking about flipping a coin. So we know with a fair coin that hasn't been tampered with at all, there's a 1/2 or 50% chance of getting heads and a 50% chance of getting tails. Well, if I flip a coin 2 times, it's not necessarily going to happen that I get 1 out of 2 or half of the times heads and half of the times tails. I might get 2 heads, I might get 2 tails, I might get 1 of each. But if I flip a coin 1,000 times, it's going to be much closer to half and half, heads and tails. And if I flip it 1,000,000 times, it's going to be even closer. So as I do that experiment more and more, the values get closer and closer to that theoretical probability, sort of what we say should happen. We already talked earlier in Module 1, I believe, about probabilities being between 0 and 1 if we write them as a fraction or decimal, or between 0 and 100% as a percent. And we talked about what it means if the probability of a certain outcome is 0 or if that probability is 1. Okay, on the next page of your notes, again, here we have this probability when all the outcomes are equally likely. We find the probability of an event by the number of outcomes that give us that event or that conclusion, like for example, pulling out a green block out of the total number. Sometimes we want to know what the probability is of something that's in an intersection of 2 sets. So it's in this set and in this other set. And sometimes we want to know the probability of getting an outcome that's in what we call the union of 2 sets. So let me just explain this for a minute before we look here. So let's say, for example, I have some different blocks, again in a bag or something that I'm pulling out of. Okay, so let's say that these are my blocks that I have. And I could say that set A is everything that's green, okay? So I'm going to write that out here so we remember. So I'm going to say that our set A is any green object, okay? And set B are the small cubes, okay? So if I look at this, set A would be green objects. I don't know, it might be a little hard to tell in the light here, but this little cube is green. So these are my green objects right here, okay? So I have those 4 objects. So if I want to say what's in set A, I'm going to say there's a square, there's a triangle, there's another triangle, and there's a cube. Okay, these are all green. These are the green square, a green triangle, and a green cube. What about if I wanted to make a set B, which is the small cubes? Well, there are 2 of those. So I can say there's a green cube and there's a blue cube. Okay, and that's my set B. Now, what if I said here, what is in set A and in set B? So what is the set that is A and B? Well, what things are in A and B? It's just this little green cube. Right? And we sometimes use some symbols. The symbol for the and, which is the intersection here, right? The intersection is where these 2 sets come together. It looks like an upside down U. So you might see A intersection B, and again, that's this green cube. Okay, well, how about if I wanted to find, okay, what's the set of items that are in A or in B? Okay, and when we say A or B, it's implied that they can be in both. So what things are in either the set of green objects or the set of small cubes, or if they're in both, that's okay. So we have the green square, we have a green triangle, another green triangle, the green cube, and the blue cube, right? These are things that are either in A or in B. One of them is in both, and that's okay. This is called the union. The or part is called the union, and the symbol for that is the upside down of the intersection. So this set could also be written like this, A union B. And we'll look at the probability of these in just a minute, okay? But the probability of picking out something that's in A would give us one value. The probability that's picking out something that's in B would give us a different value. The probability of picking out something that is in the intersection, or the probability of picking out something in the union. Okay, and we'll get to something called Venn diagrams later on, but you may remember that from another class, and that is a visual way. So if I'm saying, okay, this circle is representing everything that's in A, and this circle is representing everything that's in B, well, the items that are in both are going to be right here in this intersection. And the union is going to be everything that's in A or in B or in the intersection. So you can kind of see it visually there. And again, we'll talk about that more in a little bit. So on this page, on page 2, we see probability of A and B is the probability of getting an outcome that is in the intersection of A and B. Here's our symbol for it. A or B, the probability of A or B means the probability of getting an outcome that is in the union of sets A and B. So it's in the set A, or it's in set B, or it's in both. And again, there's our symbol for that. And we'll talk more about that in just a minute and how we find that. And that's sort of part of the tricky part of probability, is sometimes we want to kind of jump to a conclusion about what seems like it might be the right answer, but we need to make sure that we're really looking at using the mathematical part of probability. What is our answer for these? Another symbol that we need to know is A with this little slash here, and it's called the complement of A, or we say A prime. So this is the probability of getting something that's in the complement of A. The complement of A is something that is not in set A. So if I have these and set A are the purple, and I pick something, I want something that's not in A, it's going to be something that's not purple. Okay, so A and A prime are kind of like opposites. So the probability of picking something from my group that's in set A and the probability of picking something from my group that is in set A prime, those two are always going to add up to 1, because every single thing in my my group or my sample space is either going to be in A or not in A. So it's going to add up to 1. Now, another thing that we'll talk about quite a bit here is called conditional probability. So before we get to this part that looks very mathy, conditional probability means that once one thing happens, it can change the probability of something else happening. So for example, let's say I look outside and it is sunny. Okay, bright sun, not a cloud in the sky. So that already has happened. The weather is sunny, okay? Then let's say I'm figuring out the probability that I will bring an umbrella with me to work. Well, the probability of bringing an umbrella with me most likely changes depending on what the weather is, right? So if I look out and it's sunny, it's not raining, and it doesn't look like it's going to rain, or if I look out and it's pouring rain, depending on what that probability is, or that situation, probably changes the probability of whether I will bring an umbrella, right? I would say I'm more likely to bring an umbrella if it's raining, but I'm less likely to bring an umbrella if it's beautiful, sunny, not a cloud in the sky. Another example is, let's say maybe, what's the probability that you will, let's see, I don't know. What's the probability that you will order dessert if you order a smaller dinner? Okay, so if I already know that I ordered a small dinner, maybe my probability of getting dessert is larger. If I ordered a large dinner, maybe my probability of getting dessert is smaller. Okay, maybe if someone goes to a review class, that changes the probability of them getting 100 on the test, right? So it's how they're conditional. It's called conditional probability because the probability of one thing depends on or is influenced by the probability of something else happening, or the fact that something else has happened. Okay, so conditional probability of A given B represents the probability that event A will occur given that the event B has already occurred. So if event B is that it's pouring rain out, then the probability of bringing my umbrella is likely influenced by that thing that's already happening. So this, I know, looks very mathematical, a little scary maybe. So I broke it down over here. The P means the probability of. So we always have the probability of whatever's in my parentheses. The probability of A, of event A happening, given, this straight up and down line means given that event B has already happened. So the probability of event A happening once we know that event B has already happened. Okay? And again, we'll do some examples of this and kind of think about that. Alright, so let's do this example, and then I'm going to end this video, I think, here, just so each one is not super long. And then I will do a second one going on the next few pages, and the next few pages, and the next few pages of the notes, okay? When we have a set, we put it into curly brackets. These are a little tricky to draw at first, just do the best you can. So here's my example. A fair six-sided die is rolled, right? Die is the singular for dice. So I roll a die, and we have 6 sides on it. They're labeled 1 through 6, and so my sample space is that I could roll a 1, a 2, a 3, a 4, a 5, or a 6. So in my sample space, I want the actual outcomes. I don't want just a description saying numbers 1 through 6, right? I want the actual outcomes here. So let's say there are two different sets we're going to make. Event A is that the number is even, and event B is that the number is less than 5. So I want to write out what are in those sets. So if A is that the number is even from this sample space, from my die, I could have a 2, a 4, or a 6 and have an even number. If the number is less than 5, then the elements in that set are 1, 2, 3, and 4. Okay, so we've just made those sets. Notice that when it's just A or just B, that's just asking for the elements in that set. Now I have the probability of A. So the probability of A is what? Well, the probability of picking a number, of rolling a die and getting a number that is in set A. There are 3 numbers in set A, and there are 6 total numbers. So the probability of getting a number in A is 3 out of 6. How about the probability of getting a number in B? Well, there are 4 values in B, 1, 2, 3, 4, out of 6 in the sample space. So there are 6 different things I could roll. 4 of them are in B, so my probability is 4 out of 6. Okay, so now let's look at the next one. So we can see that it says what's the probability of getting something that is in A and B. And for the and the or, we'll be finding some formulas in a few minutes, but when it's something that's very visual like this with the die, and it's a little bit simpler, we have a relatively simple sample space, we can also just kind of figure it out. So I want to pick, what if I roll a number, and my number is in A and in B? Okay, so I want it to be in that intersection. Well, if I look at A and B, there are 2 numbers, 2 and 4, that are in both of those. So the set A and B includes 2 and 4. There are 2 different numbers that I can roll that will be in both set A and set B. So let's pretend the game is, if I roll a number that's in both sets, I win $1 million. Well, there's 2 different outcomes that I could have that would win me that $1 million. So my probability of getting something in that intersection, in that and, is 2 out of 6. How about or? Or means it's in A, or in B, or in both. Well, that's 1, 2, 3, 4, and 6, right? Those 5 numbers are either here, or in both. That's my set. So my probability of getting that is 5 out of 6. If for any of these you're not sure where I got them, I would really suggest that you look at the blank notes and you try it on your own and really understand where these numbers are coming from. Now with probability, you'll notice that some of these fractions could have been reduced or simplified. We generally don't in probability, unless sometimes in the homework it may ask you to specifically, but I like to not reduce them because then I can really see where the numbers came from. 2 values here out of 6 total. If I reduce it to 1 out of 3, it doesn't show me as easily where those numbers came from. Okay, B prime means elements that are not in B. Well, B is 1 through 4, so B prime is going to be 5 and 6, which means the probability of B prime is 2 out of 6. I just added those 2 probabilities, the probability of B, the probability of B prime, and we can see that they add up to 1, because every element, every number I roll is either in B or not in B. Okay, so this is my conditional probability. Let's look back here for a minute. And you may have not noticed because we were talking about what it means, but this is a little formula. So my probability of A, given that I know B has happened, is the probability of both happening over the probability of that second thing happening. Okay, so that is where I got this. The probability of picking a value, having a value that's in A, given that I know what I picked already is in B. So the probability of A and B, I had up here, it's 2/6. The probability of B is 4/6. Now this may have need a little refresher from previous classes. If you remember, when we have a fraction like this with this fraction bar, that fraction bar means to divide. So what I really have here is 2/6 divided by 4/6. And then you may remember that when we do fractions, we keep, change, flip. Okay, we keep the first fraction, we change to a multiplication problem, and we flip the second fraction to its reciprocal. Then I can either cancel out if you feel comfortable doing that, or you can multiply straight across the top and straight across the bottom. Now in this case I would probably simplify, only because 12 out of 24, there is a meaning to it, but we're not really seeing what it is right now. But let's think this one through also. So let's say I roll a die. I get a number that I already know is in B. That's my given. So I know that I got one of these 4 values. Well, looking at just these 4 values now, what's the probability that the value I got is also in A? Well, it could be 2 or 4. Half of these values are also in A. That's where this half comes from. Now the last part here is asking the other way. What if we know that we rolled something that's in A? What's the probability that it's also in B? So I have probability of A and B on top. Now I have the probability of A on the bottom. Again, I put these in here from above. I keep, change, flip. I multiply. I get 2/3. So if I've rolled a die and I already know it's in set A, my answer, there's a 2/3 chance it's also in set B. Let's take a look at that. So I rolled my die and I know I got either a 2, 4, or 6. Well, 2 out of those 3 numbers, 2 and 4, are also in B. So 2/3 of these values are also in B. Okay, so I'm going to let you kind of think about that a little bit, work through any if you have questions, really see if you understand where those numbers came from, and I will do another video in a little bit starting on page 4.